So we always start with hi everyone, and then we start with introductions if we see any new members joining. So Wei and I see one more person. Do you mind introducing yourselves if you want to, and give an update on like how you're using Argo, and then we can start off with the latest releases. Anybody wants to introduce themselves?
Okay, I can go start. So my name is Wei. So I'm working with and Financial, and I just started looking into Argo because we're trying to find a workflow engine in Kubernetes, and we want to build the entire AI infrastructure based on Kubernetes. And so because we need some workflow engine which can help you to schedule some jobs. So because it's Argo is some Kubernetes native workflow engine. So that's why we spend some time looking into. But right now we're still in the early stage, so we're trying to still doing some POC there. Sorry.
Okay, great. Anybody else?
Hi guys. My name is Yang. I'm from Google. So I'm working with Kubeflow team to try to see explore the space of using Argo to automated ML workflows. And I'm also working with Pascal, if anybody knows of him.
Yeah, we know Pascal, so yeah. Great. Yeah. Thanks, Wei and Yang. We will start off with Wei, since you're new to Argo workflows. If you have any questions or if you're facing issues with getting onto Argo workflows, let us know. Yang, I am assuming you have been using Argo workflows.
Right. I think I've seen Yang on our meeting before.
Okay,
yeah.
Great.
Yeah, yeah I just never speak out.
Good to see you again, Yang.
Yeah,
yeah, nice to see you.
Sure. In the meantime, so Jesse, you want to start off with the update?
Yeah, sure. Okay, so I can share my screen.
Yeah.
Okay. So I just had planned to kind of go over the 2.2 release and just kind of highlight some of the features that were implemented in the latest release, and then I'll do kind of the same with the Argo CD release. Actually, we have a 0.9 release coming for Argo CD, and then I'll be highlighting some of the features coming in Argo CD 0.9. So let me know if this is, because this release happened I think a few weeks ago. Let me know if like I'm wasting people's time. But I'll try to just highlight the most important points, kind of give some demos of these new features. Okay, so this is the changelog of 2.2. We'll just start at the top. So I think one of the big requested feature was how do workflows can you, if you're using loops, how can you aggregate the results of loops? So one of the big features in 2.2 was the ability to perform parameter aggregation of these outputs in a loop. And we don't yet have artifact aggregation yet, but this kind of is just highlighting, this is showing you how you can aggregate parameters. So the idea is that you have a step that produces use loops in that step, and it produces a list. So in this case, this is that step. This step is essentially producing a list of structs, and each struct is saying whether that number is odd or even. So this is an example of the output of this step. And I'll make this a little bigger. And the idea is that with parameter aggregation, you can then reference this whole step's output as an aggregate list. So then you take that step and you pass it to the next one, and you can use that as as a list expansion again. And this step is actually filtering out just the even numbers from the previous step. So that was kind of a big limitation that pre 2.1 was that, okay, we can use loops to kind of fan out a bunch of parameter outputs, but we had no way of taking all that and fanning back into as an aggregate. So this is the new feature in 2.2 that allows you to do this. So we are discussing how to achieve the same thing with artifacts, which is a little bit trickier because we have no construct to reference a list of artifacts, unlike parameters where list was a kind of already an existing feature. Referencing list was already a feature of Argo. So this workflow, it looks like this. So here we saw that it produced a 4-element list, and then when it referenced the outputs of that list, it applied that filter where it filtered just the evens, and then after that filtering, it went to the third step, which only operated on those even numbers.
So before we could have had like a non-parallel step, which provided a list of things that we could then iterate kind of in the next step. But now we could generate the same list using a parallel set of steps.
Yeah,
it's one way to do it.
Yeah. So I think that the next step is to find the right syntax on how to achieve the same thing, but with output artifacts and instead of just output parameters. So Ed has some ideas on a good.
Actually, there's a GitHub issue where we're having some discussions on this topic. So if this is a feature that you might be using, being able to aggregate artifacts as output of a parallel step, please chime in on that issue.
Okay. So another big feature was just earlier. It was it's hard to get insight on what was going on. We had no pending state for our workflow. So I'm actually going to submit another this workflow again. So another big feature was that we now have a pending state for our nodes. So and if you watch the pending state, we will capture the reason why it's pending from the actual pod manifest.
Oh, okay.
So it will also, so if it's because there's not enough nodes or not enough memory, those will be highlighted in the message of the of that pending node. The other thing is that there's a watch command in Argo CLI. So if you submit something, you can say --watch, and this actually brings up a basically a little mini UI in your console to watch it live as it's happening. So that makes it pretty easy to kind of monitoring workflows from when you're submitting through the UI. Sorry, CLI. Okay. So stop me if you have any questions, or if there's a particular feature that you wanted to want me to go over. Let's see. Okay, so this is an interesting one. We got a nice submission from Datadog to support a additional runtime through kubelet. So some very secure clusters don't want host volume mapping especially of docker.sock. So if you have a secure cluster, chances are your cluster admins are not going to permit a host volume mapping of files on the Linux host. So this contribution was actually supported the ability to use kubelet to to perform some of the tasks that the Argo exec sidecar was doing, namely being able to copy out artifacts, get the logs of the main container, kill any sidecars that were running. So this is still kind of experimental, and I think artifacts is still not working the last time I checked. But basically, you can switch your executor to a kubelet-based executor if your cluster does not permit host volume mapping. Down the road in the future, we're actually going to use a new upcoming feature in Kubernetes called process namespace sharing, and this will be basically the best kind of solution for running workflows in a secure manner. The idea behind process namespace sharing in Kubernetes is that your containers and your sidecars, all the containers, you can choose to have them run within the same process namespace. And what that means is that the tasks that are needed by the Argo exec sidecar, for example, like killing, copying artifacts, if they run in the same process namespace, they actually have direct file system access to the main container. So like the root file system of the main container is accessible under like procfs of the Argo exec sidecar. So he can actually go and grab artifacts within procfs, and this is possible with a true-false flag in a pod manifest. So basically the idea is that the workflow controller, when it's creating these workflow pods, they will set process namespace sharing to be true, and then the Argo exec sidecar and the main container will be sharing the same process namespace, and then the Argo exec sidecar can kill and collect artifacts.
So this would be similar to, say, running your pod with hosted, except the sharing is only within the pod and it would not be considered a privileged container.
Yeah. So that's the future. I think once we get that, and it's still an alpha feature in Kubernetes, so it won't be available unless the feature gate for this is enabled. But this will be the future. Then we will be able to support essentially any container runtime, regardless, like if it's Docker or containerd. Basically, we won't care at that point.
Right. Yeah. I mean, one drawback with the kubelet executor-based approach is that you do have to configure your kubelet and API server to use webhook authentication and also token-based authorization. So most clusters probably are not configured to work that way. So it basically a bit some additional work in order to use that.
Okay. So next, I'll cover the next two, which is one of the features. So with Argo 2.1, all artifacts were tar-gz'd when they were saved to the artifact repository. And similarly, when we were loading them into the container, we could only accept either a single file or a tar-gz file, and load that into the container. With this new feature, we can actually upload artifacts to a S3 bucket in a without tar-gzing it, and we can also download a quote-unquote directory, a S3 bucket directory as an artifact. So I'll show you what I mean with this feature.
Make it a little bit larger.
Okay. Okay. So I have this test workflow called artifact disable archive, and if we go to this workflow, okay, the interesting part is the how it's laid out when you actually go look at the workflow. So this I'll just choose any one of these. so this first step that I just clicked on was the one producing the artifact. So if you see that there's no targz files here, so this workflow had two artifacts. It was a one file and one directory, and the directory I chose to archive was /etcd. And basically the whole contents of etcd is actually just uploaded recursively as it's as a expanded file, a directory on S3. Similarly, this workflow actually downloaded that whole directory, S3 directory, as an input artifact. So let me bring that. Okay, so the way you use this is that when you specify your outputs, you will have basically you have an archive section, and you can say none. So both of these, this is the first step when you're generating outputs. It says I have I have a location called etcd, and I don't want you to targz it. And then on the second step, it's actually it's still referencing the previous artifact in the same exact manner as before, but we are able to load a directory and understand it's a S3 directory and load it into the container. The other feature you might have noticed is that the path layout was kind of this is customizable. So I have it currently set up to use the year, month, and date, and the workflow name as the archive location. And the way you actually can configure this is in your workflow config map. So there's a new a new field called key format, and here I'm saying put artifacts under my artifacts, and then the year /month/day, and then the workflow name, and then the pod name. And you can use stuff like workflow UID if you need like true uniqueness. You can use the workflow namespace if you care about namespace. But this just gives you a little more control about how you want to store things. Okay, any questions so far? All right, let's kind of pick and choose some other things I felt it was interesting. Oh, okay. Termination is a new thing. So basically, there's a new command in Argo where you can actually say Argo terminate. And the difference between Argo terminate and Argo and kubectl delete or Argo delete is terminate will actually send a kill signal to all of the running pods, and it actually won't delete any pods. So the Argo exec sidecar will attempt to gracefully kill the main container, and then if after 10 seconds it doesn't come down, it'll kill those the main container, but it will leave the pods. It'll leave the pods around. So you still have that ability to get the logs of terminated workflows, unlike kubectl delete or Argo delete, which will actually just delete everything, and you have no way of kind of debugging workflows. So that's Argo terminate. And I think the last one I wanted to cover was GC. Yes. Okay. So it's now possible for the workflow controller to automatically GC a workflow. So it will actually delete the workflow after this field. So Jeremy from the Kubeflow team kind of pointed out that there's this upcoming feature in the jobs, in Kubernetes jobs, the same exact field name. It's called TTL seconds after finished. So in Kubernetes, jobs are going to get this feature to delete jobs on an automatic basis, and it's in seconds. So we basically copied the exact same syntax that jobs has and said, workflows will also be deleted after a certain number of seconds after the workflow completes. So I'll just submit this one. So after this, okay, so right now it's still there, and if I run it one more time, okay, it's gone. So this is kind of a lot of the problems a lot of people having is that they submit workflow, but no one cleans it up. And we have this problem ourselves. So this feature will let you kind of give it a lifetime.
Did you also have one about saving logs?
Oh yeah, okay. Yeah, log archiving is a new feature. So in your workflow config map, there's a new field called archive logs. And so all of my workflows have been archiving the logs of all of these things that I've been submitting. And what you'll see now is that when you go to your S3 location for a workflow, or specifically a workflow pod, there will be this main.log, which is actually the entire output of that container when it was running. And we now we have the ability to archive that as a artifact. So then your logs are kind of stored permanently.
Now you don't have to worry about your pods being GC'd and then you lose your output.
Yeah, that's right. And I think there's on the next patch release. Right now this is kind of globally scoped, but in the next patch release, there should be a way to set this at a template level, saying I only want to archive the logs for this one template.
Questions?
Yeah, any questions so far, or anything you see here that
feature-wise,
yeah.
Any requests?
Yeah, this one had a lot of usability and a huge payload in terms of usability. So it was kind of just catching up on a lot of the feature requests that had accumulated.
So
okay. Oh, sorry. Go ahead. Yes.
So for the new command terminator, so the purpose of the terminator is just for grab the logs, or how do people use the terminator command in reality, besides of the check the logs?
Yeah. Okay. So let's say you have like a huge, like a long running workflow, and it did like a lot of good work, but for whatever reason it just got stuck. I don't know. Like you have something. So if you still want to keep around the metadata of that workflow, like you do like to know like how far it got, and you want to look at it on the UI. You don't want to actually delete it. If you say Argo delete, it's going to delete all the pods. It's going to delete the workflow itself, and you lost everything except maybe the artifacts will be still around, but you lost the workflow metadata. Terminate will make sure all the pods related to that workflow are no longer running, but it won't actually delete the workflow. So you have the metadata of that workflow kept around for whatever reason, for whatever purpose.
So you could use it for debugging.
Yeah.
Now, can you resubmit or retry a workflow that's terminated without deleting?
Yes.
Okay.
Yeah.
So another use then would be to ensure that the intermediate artifacts are still around.
Oh yeah, that's a good
resubmit.
Yeah. Yeah. So that same scenario that I just mentioned, like okay, it was running great until this one step, and then it got stuck. But I know that if I just retry that one step, then it will like progress. So terminate would be very useful there, because you would terminate the workflow and immediately say Argo retry, and it would kind of start where it left off. So that would be a good use of terminate.
So the retry will start from the last step before the terminate, right?
I think it'll basically rerun any steps that didn't finish successfully.
Oh, the semantics about retry?
Yeah.
Yeah, retry, the way retry works is it essentially erases from history anything that it that failed. So it rewrites the workflow in a way that it acts as if those failed step never even happened. So then when the workflow controller picks this workflow up again, it thinks, oh, I have yet to run this step, and then we'll schedule the pod related to that step.
So a big advantage is that it'll reuse all of any intermediate artifacts that's already been generated. So very convenient for debugging or if you are experimenting.
Yeah.
Mm-hmm. Okay, thank you.
Okay. Yeah, feel free to post any questions about some of these features in Slack.
So just to do a time check,
Yeah.
after this you'll do the Argo CD, and because Matt and Vaibhav are also in the call, they can give an update on this.
Maybe just very quickly to say what you're thinking in terms of 2.2.
Yeah.
Oh, yeah. So I've been 2.2. I kind of haven't thought too much about because I switch back and forth between workflow and CD. But I think the next big things will be the pod priorities and queuing. I think those are kind of important things.
So supporting the new priority class feature.
Yeah. So up until recently, Kubernetes had the priority class as an alpha feature. I think it's out of alpha, so now it'll be generally available. So the idea is we can now leverage the existing pod priority, or at least copy some of its the semantics about pod priority into workflows, and then kind of leverage that feature in Kubernetes.
And what about artifact aggregation?
Artifact aggregation would be, I think,
also.
Yeah. And if you guys have inputs on what you feel are important too, let us know. Like, feel free to let me know right now if there's a particular feature that you are looking for.
Okay. Go to Argo CD.
Okay. Argo CD. So this is what's coming. The big kind of anchor features is we have automated sync policy, meaning so now actually prior to this, if you have an application, let me switch gears. Okay, so this is Argo CD for those of you unfamiliar. So over here I have three apps: a guestbook app, Minio, and another guestbook. So the idea behind autosync is that previously someone or some automation script would have to go here and actually, if I want to deploy, I go to this thing and like synchronize. With autosync, we will now detect when we are out of sync according to the manifest in Git, and automatically sync when we detect that we are out of sync. So here I'll just do a really quick example. So this guestbook app is tracking my fork of the example app. So what I'll do is I'll edit this and I'll change this to version 1. I'll commit this. This should okay, good. This detected we were out of sync, and it initiated a sync automatically. So here we see this thing coming up because I went back from 0.2 to 0.1, and it's actually had performed the apply, and it's doing the in the middle of doing the deploy.
So previously, one would typically invoke Argo sync as part of your CI/CD process, correct? Which require configuring things like Argo CD credentials in your CI process.
Yes.
But now it can be, the deploy can happen automatically without the CI, so less configuration, at least on the CI/CD side.
Yeah. So the advantage, and we've worked. Flux has a great article about why you don't want to give your CI pipelines credentials to your cluster. So this, if you believe in that, and you would have your CI pipeline just make a git commit and push, and you have the deployment tool perform the deploy for you, like without having some imperative step from the CI pipeline to perform the sync. So that's autosync. It's a toggle that you choose per application. We also in 0.9 we will be supporting EKS. So EKS has a different authentication scheme. It uses formerly known as Heptio Authenticator. So we now support EKS. Token management is now available to be done through the UI. So if you don't have autosync and you prefer to perform syncs through some automation, in 0.8 we introduced the ability to generate tokens, and you can now have a UI to help you manage that. We started exporting Prometheus. We have an endpoint now for Prometheus metrics. So if you want statistics about your applications, we have an endpoint that can be scraped by Prometheus. The API server is now HA. If you choose to, you can run with multiple replicas. Okay, and just a bunch of other. Oh, okay. One big thing is that if you like Helm and Helm charts, we have much better support for it. So for example, I actually have the Helm repository registered in this cluster. So so a lot of improvements were made to support kind of the Helm isms that we were hitting before. So it's a lot better support for deploying from the Helm repository.
So this is scanning the repo and automatically picking up all the charts. Right?
Oh yeah. So yeah. Sorry. What you just saw was when I selected the Helm chart. It actually shows me these are all the charts in Helm/charts, and I don't think everything works on this, but a lot more works now with Argo C. Okay, I'll stop here because I think I took up enough time.
Okay. All right.
Okay, cool.
Thanks, Jesse.
Yeah.
Matt Weber, you want to go next to give an update on Argo events?
Hi guys, can you hear me?
Yes. Hey, Matt.
Hey, hi guy. So maybe I'll start and then Vaibhav can take over since he's doing most of the work on this update. So yeah, we kind of are like evaluating certain use cases internally for kind of like automating our workflows. And we kind of like saw some pitfalls that the existing architecture kind of like didn't enable us to support. So Vaibhav has been taking on kind of this big project to re-architect the Argo events project to add gateways as well as sensors to kind of work together. And it kind of solves a lot of the problems that we were running into on the existing design. So maybe I'll just hand it right over to Vaibhav and he can kind of walk through some of the things that changed. I don't know, do you have the PowerPoint that you have, Vaibhav?
Yeah, I can share some architecture diagrams.
Sure.
Before that, I wonder if you could say just a little bit. Of course, not long ago, the Knative project was launched. I wonder if you could just say a little bit about how Argo events relates to Knative.
Sure. Yeah, Vaibhav, please jump in and just fill in wherever I leave off. But I think we were both like kind of interested in the Knative project, and we were looking at it at the beginning when it came out, and we were evaluating the differences that between our existing platforms. And one of the things that Knative was really was really great for Knative was that it gave us, you know, like all these like different objects, and then you can kind of like the clients and the actual like, you know, subscribers, they wouldn't have to be created at the same time, and you could create, you know, the subscribers after, say, events were published from some event source in the first place. And these were all like great things, but we also ran into like issues like the actual deployment of Knative itself. It was tightly linked at the beginning with the build, and I forget the other one, but it was all
Yeah,
three.
it's a serverless platform that they offer. Yeah.
Yeah, so all three of their components, like build, server, and events, were kind of like tightly linked and kind of like working together very nicely. But we kind of only wanted the one piece, the eventing piece. So they were using Istio and a bunch of complex deployments, and it seemed like very over the top for us for what simple purpose we wanted to accomplish. So maybe if you guys just give you a little introduction about what we've done, maybe after that we can talk a little bit more about the differences between these two platforms.
Yeah. So like as Matt said, like the Knative framework, yeah, it offers many things, but our focus is mainly on eventing piece. And what we want Argo events to be is simple to use, simple to understand, and very much extensible. So for that, we created something called gateways. Now you have sensors, and now you have gateways. Gateways are specifically generating events or listening for some external events. The sensors are one who are taking the action on those events, basically triggering a Argo workflow or creating a new Kubernetes resource. So your gateways are like long running, so they will keep on running. You can configure your gateways in different using different configurations. So a particular gateway can have many configurations and it will keep on running. So we are like resolving the issue of like repeatable sensor, repeatable workflows and stuff. Like because your gateways are continuous, it will process the event, or it will generate the event and send it to a sensor, and all sensor needs to do is trigger a workflow. So can you guys see my screen?
Actually,
Yeah,
if
so
you go to full screen, it may be easier for us to read the.
Yeah, or maybe just zoom in, or if you have examples on your computer.
and right now, is it visible?
The size didn't change for me.
Oh, there it goes.
Okay, there you go. So on the left is the same.
No, yeah, it's the same size.
It got wider,
just zoom in a little bit.
Yeah, sure. Yeah, give me a sec. Yeah, sorry. Yeah.
Okay. That's it.
Cool. Okay, so on the left is a spec for the gateway, on the right is a spec for the sensor. So in a gateway, you specify what are the watchers for this gateway. So watchers are basically, it can be another gateway, it can be sensors. We are adding watchers in gateway spec right now because we dispatch events between gateways and sensors using HTTP protocol. So we need to know where exactly to send an event to, but we are planning to add Kafka and NATS as an event dispatching mechanism, so that gateway and sensor, they don't really need to know about each other, and gateway can just publish event to a Kafka or NATS cluster, and the sensors can then subscribe to that particular event and then kick off the workflow. On the sensor side, you can see there is like signals, and in the signals are basically events from gateways. It's in the format like gateway name / a particular configuration that's running within a gateway. So for this particular signal on the sensor on the right, it's like interested in two different signals. First one is webhook gateway with the foo config, and second, same gateway with the bar config. And after that, once it gets the events from these two configurations, the rest of the sensor operation is same. It's going to trigger Argo workflow. Also, the important architecture difference between the previous sensor, like just sensors and signals, and now gateway and sensors, is like you can easily extend the gateway. When I say easily extend the gateway, we offer different types of gateway. First one is a core gateway style, where you can write your gateway in Golang and like follow the same pattern that we did for the core gateways. Or if you don't want to write your gateway in Golang, you can choose any language that supports gRPC. And if you don't want to write in gRPC, you can also write your gateway in HTTP, and it supports any language that basically support HTTP protocol. So this is a simple architecture of the core gateway. The configuration watcher and the gateway transformer are the framework code. So all you need to provide is a configuration runner. The configuration watcher is continuously watching a config map for a gateway. Whenever new configurations are added or removed, it notifies a config runner, and then config runner can take action on that. So you can when your gateway is up and running, you can dynamically add new configurations or remove remove the existing configurations. So this is a core gateway style. The gRPC, you can create .protofile, implement the interface, and your code will be the gRPC server. The framework code will be the gRPC client. And there's the same story with the core gateways. The client sends configuration to server sends events back to client. And then there is the HTTP gateway, where we have HTTP servers running. It's the same thing. Client sends configurations to server, and events are sent back by the server. And then there is a gateway transformer. So gateway transformer remains the same throughout all types of gateways. Its job is to like get the event out of the gateway processor client, convert it into cloud events specification basically, and then basically dispatch that event to the sensors that are interested in listening to this particular event. Once we add support for Kafka and NATs, gateway transformer is basically going to publish it to the streaming cluster. So we in a gateway spec itself, you can mention what type of dispatch mechanism you would like to support, whether it's HTTP, NAT, streaming, and the gateway transformer takes care of actual dispatching the event. So over here, you can see dispatch mechanism. Right now, it's only HTTP supported, but yeah, there will be NATs and Kafka addition as well.
Now, before we had something called signals, right? And then
yeah, the signals are they are gone. They are out of the picture now, because signals are kind of now replaced by gateways, which are kind of like long running. So you can if you still want stick with that, you can consider gateways as kind of now long running signals basically. Yeah.
Yeah, and also this kind of like moves towards a pub sub mechanism, which kind of is a natural fit for this domain. And I think we during our initial learning of Knative, we kind of like okay, like they have some good ideas about building upon a pub stub style system. So we a lot of the gateway is being long running, and then they act as publishers, whereas the sensors on the total end of this eventually will act as subscribers in the system.
Okay. Yeah. Yeah. Of course, a lot of people have asked for the ability to process recurring events, and the gateways would be the way this is implemented.
Yep.
Cool.
Does anybody have any other questions about this stuff? I mean, this is we're still under like actively developing this feature.
Okay, cool. Yeah, actually, I'm looking forward to using this. I want to set up kind of automated workflows for kind of it's like I guess a Kubernetes type of thing for automatically picking up workflows and jobs. We're starting to engage more with the kind of the machine learning folks at Intuit as well, and so we're kind of helping them set up this kind of infrastructure. Hopefully, we can also interest them in stuff like Kubeflow as well.
Cool.
Okay, I think that's all we had for today. Unless anybody has any other questions or wants something in the roadmap.
Everyone's happy with the current feature set? Okay.
Okay, then I guess you get back your 7 minutes. Thanks everyone for joining. See you in 3-4 more weeks. Thank you.
Thanks.
Bye.
Bye.
Thank you.
Bye.